Welcome everyone. I'm Dietrich Neumann, the director of the John Nicholas Brown Center for Public Humanities and Cultural Heritage, and I'd love to welcome you to another lecture in our series on New Voices and New Directions. And it's really a special pleasure to have Lara Davis with us, who's zooming in from Auroville Earth Institute in India, where she is working. And I'm particularly thrilled, as many of you know, we've sort of been discussing public humanities in a wide range of contexts, and this, in a way, is a really important context, both for its global reach and for its look at architecture, or rather building practices that can really fundamentally contribute to a more equitable and inclusive and fair society, and contribute to better conditions for the urban and rural poor. And so it's, I think, a fitting addition to this wide range of voices that we have heard. And Lara Davis is an architect and a shell builder. And her work, as many of you, of course, know a little bit about architecture. Some have been to my lectures, of course, on Antonio Gaudí and others. And the shells that were used by Catalan builders at the turn of the century in their quest for culturally meaningful, different architecture that, of course, is now a huge tourist draw for Barcelona. These builders used a approach to architecture that has been revived, among others, by Lara Davis and also by John Oxendorf at MIT, who was her advisor for her thesis. When she got her Master of Architecture there. She also has a BFA from the College of Ceramics, School of Art and Design at Alfred University. And she has done a lot of work at the Institute for Lightweight Structures and Conceptual Design at the University of Stuttgart. Again, my students know that's the place where Frei Otto invented his incredible roof structures in the 60s and 70s that ended up in the Olympic tent. And so she has all these wonderful connections. We'll see much of her work in a second in Auroville, where she's calling in from. Just two more or a few more details. Her work is really very practice oriented. So she has been a mason and a foreman and project manager for countless buildings in this really fascinating rediscovered way of creating timber walls, as they are called. Her thesis, by the way, won a big award at MIT for this four-dimensional masonry construction, wonderful term. And so she has worked all over the world, in Ethiopia, and of course in Zurich at the ETH, where they also do structural work, and has led workshops in England and in Boston and in New York. And of course, we hope to bring her here in person at some point. So this is only the beginning of a long conversation, but it's all super exciting. And I can only say that I'm more than thrilled to welcome Lara Davis, and please help me virtually welcome her, and we'll switch over to her at this moment. Thank you, Lara, for joining us.
Wonderful. Thank you very much for this very warm introduction, Dietrich. I'm flattered, actually, that you've done your homework so well on me. But it's nice now that we've been communicating over a period of months, and it's inevitable that I come back to Rhode Island, as I have family there, so I do look forward to coming to Brown. So I'm going to see if I can kind of balance here between the projection screen. So I think I'm also on video and also with a screen here, but just give me a second to settle in. The question that I'd like to pose in the lecture for today is, can buildings improve local ecologies? And oopsies, 1 second, let me just get it so that I get the slides going. Oops, that doesn't seem to be changing, does it? Oopsies. Do you see my slides changing?
Nope.
No. I'm going to have to try this one more time. Okay, from the beginning. Forgive me, I think that we tried this in advance, but somehow this is not working. So what we need to do is now go from the beginning. Aha, okay, yeah, sorry. Okay. So, can buildings improve local ecologies? This is a LEED rated building in the Boston area. And I think that we can all agree today that the benchmark for sustainable construction is being set by buildings like this that are predominantly representing the corporate elite. So we have platinum and gold LEED rated buildings with a very heavily satisfied tick box of additive building technologies and high embodied energy and high carbon emission, high carbon emitting building materials like concrete, glass, steel, and aluminum. But again, the question I like to propose for this is sort of the thesis question of the lecture, is the rhetoric of sustainable design is taking this position of mitigating impact of construction, at best limiting embodied energy and carbon footprint of buildings. But can we go further than this? Can we look at a whole systems co-design of ecologies and buildings to discover how buildings may be used to improve local ecologies? Here's another LEED rated building from the Boston area. And I think that it's interesting for me when I found this World Green Building Council that they're identifying green buildings as building that in its design, construction, or operation reduces or eliminates negative impacts, and it can create positive impacts on our climate and natural environment. So I'd like to propose that we're actually a very far distance from the latter, creating a positive impact for our climate and our natural environment. But I'm going to show mostly two projects today that are hopefully moving in that direction. So for green materials and green buildings, the building materials that I listed before, aluminum, steel, glass, country fire brick, even reinforced concrete, we can see that the second column here is embodied energy, and the third column is carbon emissions of the building materials. That for all of these LEED buildings, we have extremely high values of embodied energy and carbon emissions. And at the very bottom, we have CSEB, which is compressed stabilized earth block with only 5% of cement stabilization. So that's one of the building materials that I'm working with a lot, and it's specialized at the Oroville Earth Institute. So we have a huge, huge difference. How much embodied energy is in these buildings? I just skipped to LEED accounting systems basically prioritize green technologies, which are often in themselves very high emissions and embodied energy technologies over initial embodied energy and over life cycle analysis of buildings. But at the Earth Institute, we're dealing with earth. We're dealing with one of the lowest carbon emitting, in fact, a zero carbon emitting building material in theory, very low embodied energy. And we can start with the initial values being extremely low. So this is a collection of soils that we have here at the Earth Institute. And I'd like to tell you a little bit about soil before I show you some projects. Soil as a building material is basically all soils can be adapted for construction purposes, or almost all soils rather. We have a very wide range of climatic contexts that we can work in. Soil is always locally available and abundant. It's inexpensive. It is zero energy for production. It has a very low carbon footprint. It is 100% recyclable, or it has a circular ecology of use, and it reduces the use of imported materials. Also, from the social side, we can say that it's labor-intensive construction methods, meaning, which is an important argument for us, that it invests heavily in local economies, local value chains, and human livelihoods, as opposed to just imported materials or technological methods. So this is just an image of rammed earth. If we take 1 cubic meter of rammed earth, just to give you an idea of the complexity of the material, This will have more than 600,000 trillion grains, individual grains in that material. So it's a granular matter. It's very complex. We call it soft matter because it behaves both as a solid and it also flows like a liquid. Soil varies infinitely in its grain size, in its texture, in its color, in its behavior. We have such a wide range of different clays that can be found in different earth samples, and therefore the behavior of each soil sample is extremely different. I'm going to skip a little bit of the technical stuff here, but basically we have electrostatic force in clays. Clays are the living particle of the soil. They're what bind the soil together. Clays allow us to absorb and release water. Therefore, we can have swelling and shrinkage in clays and in earth, and that gives us breathing buildings. So it means that we have to figure out how to stabilize the soil and how to make it stable in buildings, but it gives us benefit for the human comfort in buildings because we can use it as a natural way of breathing in the building, and we'll talk about this in detail. So as we add water to clay and to different types of earths, we have such a wide range of different behavior that it can be adapted to many, many different types of techniques. And on the left is adobe, on the right is compressed stabilized earth block. So we can use earth in a raw state for construction, or we can stabilize it with cement, or we can stabilize by many other different types of processes. In this case, cement stabilization and mechanical compression is one great way to stabilize soil. Oops, back. This is compressed stabilized earth block that's produced here at the Earth Institute. And we have, depending on how you count, between 12 and 14 different earth techniques. These are a series of some of the different techniques as we vary the amount of water in the mix. I'll show some examples. And this also gives us an incredible variation of textures and language and in a human landscape, in a built environment, from adobe to wattle and daub. This is laterite block, cob, plasters, rammed earth, and compressed earth block. So these are just a few of the different techniques: rammed earth, compressed earth block, poured earth, adobe, wattle and daub, and cob. And I'm not going to go a whole lot into the different techniques, but just important for you to understand that the techniques are so varied in their nature that we have a wide range of different morphologies of building materials, thicknesses and thinness, so we can really take different earth techniques and adapt them to local climates, rather than just taking like one imported building material. We can take the earth itself in a local place and adapt it to a technique that's best suited for local place. But it's said that about 50% of the world population now lives in earthen buildings, and here in the orange you can see the areas where vernacular or traditional earth building can be found, and basically on almost all continents with the exception of Antarctica and up in the polar regions. And there's a concept that that I really love called earthen cultural landscapes. This is an aerial view of a settlement in Algeria, where we have basically in vernacular architecture a total co-development of human habitats and natural landscapes or local ecologies. And that's mainly because in traditional societies, in vernacular culture, people have a very a highly attuned idea of what materials should go where. So what materials should be used for buildings, what should be used for infrastructure, what should be used for agriculture, and therefore the local place can be shaped very appropriately. This also goes for cold climates. So now I'm going to show you an example in a cold climate, but this is a rammed earth technique that's used in Tibet. And just around the corner from my building site, a monastery called Key Monastery that's 11th century, you can see how the local vernacular architecture has been shaped around this mound in order to optimize for the sun throughout the long, cold hours of the winter. So this example is a project of the Earth Institute. I was on site as supervising architecture for the architect for the construction is Casa Eco Community Center. And so first it's earthquake resistant and climate responsive, but I'd like to say that I'd like to propose that there's a sustainable co-development of natural ecologies and human habitats with this project using passive design methods, low carbon materials, and circular ecologies of natural resources. So let's kind of now test this theory. This is an image of rammed earth from the site itself. This is based on an 800-year-old technique. Looks pretty pretty simplistic in this image here of Tibet, but it's actually very low strength ramming with this particular rammed earth. It's not at all like the high strength ramming that's often found in European rammed earth buildings. And so you find this technique looks very rough in texture like this. So there's a lot of gaps of air and water that's found in the cross section of the wall. And it's not at all because it's a crude technique, but it's because there are winters of minus 35 degrees centigrade, summers of plus 35 degrees centigrade. Just for the Americans, I give you Fahrenheit here, minus 31 Fahrenheit to plus 95. That's a huge annual fluctuation in temperature. And the diurnal or the daily fluctuation in temperature is just as great, extremely cold in the night, extremely hot in the daytime. So this low density, high thermal insulation building material has been shaped exactly by this climate. We have thermal mass and hygrothermal behavior. So thermal mass is basically the time it takes for the solar energy to be transferred through the cross section of a wall, and that can passively warm a place in a cold night. So where we have temperate climates or cold climates like this, we can really beneficially use thickness of the wall in order to act like a battery for warming people in the evening. There's also something called hygrothermal behavior because the clay is living. If it's cold outside and it's warm inside, we have condensation heat that's actually being generated by the clay particles itself, by the earth. So because it's a living material, we have this extra warming that's happening. Its opposite is also true. If it's very warm or hot outside and it's cold inside of the building, then we have evaporative cooling, meaning that the wall is passively cooling the inhabitants and creating a much more comfortable interior environment. So this is like, because the clay is a living particle of the earth, and we can really benefit from it. Now, in this building, we've also used tram wall systems, which is a double facade system using basically an upper and lower ventilator to create convection in the building itself. So here's a lower ventilator, here's an upper ventilator, and then we have the window opening that's basically operable. In this case, if we're in an environment that's extremely cold in the wintertime, like I said, minus 31 Fahrenheit, in this case, we had some measurements. It was minus 8 degrees Fahrenheit outside, And we were able to measure that it was plus 50 degrees Fahrenheit inside of the building. And this was achieved in the wintertime with absolutely no other heating of the building. No, there's not even a potbelly stove in this place. It's completely passively heated, which means that we don't have to deforest any of the neighboring areas. This place is above the tree line itself. So by technologies, simple technologies like this that are adapted to place, we can be designed very sensitively for the climate and design very sensitively for inhabitants. They don't have to waste money, important money on shipping timber, a 12-hour drive in from the outlying areas. So a few final images of the building with a trom wall system from the outside. This is the local area of Spiti Valley, in this very remote valley. Wood is being recycled from one generation to the next because there is no timber in this area. We have plaster clay that's extracted from deposits along the riverbed, and we have earth that's basically recycled from every other generation in the family. So it's total circular ecology of building materials. And then we get a kind of aesthetic of a hybrid of local materials, traditional knowledge, and a few very simple new technologies. On the north side of the building. Voila, so there. So the question is, have I gotten yet to how does a building improve local ecologies? Not yet. Maybe this project gets to a sort of co-design between local ecology and building, but it's not actually trying to improve the local ecology quite yet. So, but this is a direction I think really all architects need to begin to ask themselves in the coming decades. And I think maybe this next project that I'm going to show you, which is Sharnham Rural Development Center, might get at this just a little bit better. So this project was built, now we go from cold climate in the Indian Himalayan belt to hot, humid monsoon climate. This is in Pondicherry, India. This is just about 20 minutes drive from where I am in Tamil Nadu right now. And the site was something like this. It was a large excavation, a soil excavation that had been used for roads, very badly planned excavation. What normally happens when we have unplanned excavations, soil excavations in monsoon climates, is every monsoon we have heavy rains come, sometimes up to 1.5 meters of rains, and they erode all of the arable soil, all of the topsoil washes down to the sea, and then we lose this important water. So it's so hot here and so dry here in the summer times, but like the survival of the local ecology really requires that for those 3 or 4 weeks of the monsoon season, we capture as much water as possible and extend that through the period of the year. This coupled with the fact that India itself, and particularly Tamil Nadu down on the lower right, they're some of the highest water stress or water scarcity levels recorded on the earth right now. There in this area, as you see Pondicherry just about in the middle here on the right side, there is a system of traditional what's called eries, which is water tanks that are Chola era water management systems that can be found in this area, but most of them have been silted up. So most of them have been neglected for a long period of time. But traditionally, these tanks were dug to be able to capture as much water as possible. And I'm not sure if you can see here, this is a place called Usteri Lake. That's right where the site is. Usteri Lake is the significant watershed for the entire settlement of Pondicherry. So this area where we have this huge, massive, big excavation is the most important area for water scarcity, or for basically climate resilience of the entire region. This project, called Sharanam Rural Development Center, is a low carbon campus that we like to say is contributing to regional land management and climate resilience. About 76% of the building materials used for this construction were extracted from the site itself. And I'm going to show you some images of the conference hall building. So the entire site, which was already a very poorly managed quarry, we had the opportunity to resculpt the entire landscape, and in this case, extract a huge amount of soil, of earth, that's used for construction purposes, and just displace this by about 100 meters on the site in order to create large tanks for water repercolation that help recharge the local water aquifers. This is so critical, both to maintain water over a long period of time and to recharge the aquifers as much as possible. Get an idea of the scale of some of these recharge areas, but all of this soil could then be used for construction. And in this case, you see an exploded axon of the conference hall. I can skip to it, but just to mention, we have the walls and the roof system of this are mass systems. So we have thick walls of earth concrete and a large vault of compressed earth block that is using as much earth as possible in the construction. Here's a cross section of the building. In this case, we engineered a very extremely thin shell structure with a span of 15 meters, maximum span. That's a max span of 49 feet, just about. So for that span, this is around the thickness of an eggshell, just a little bit more than that. And as I mentioned, we have load-bearing walls and also foundations with something that's called poured earth concrete. So it's a superstructure. It's very low carbon material, very low strength concrete that's using 50% of earth. And it's basically cast similarly to a conventional concrete. So it means that people can easily adapt well-known methods in order to work with a very unconventional building material. So we don't have to teach people who know about concrete a significant amount as long as the engineering for the material has been done well. This is a view of the vault itself. It's built with a free-spanning vaulting technique developed by the Earth Institute. So we have compressed earth block that's been laid vertically with stabilized mortar. There's no formwork at all that's required for this construction technique, just a series of string lines or masons lines to guide the masons and laying block in situ. A few images of the construction of the vault. So we have a large roof system. We don't, in this case, we don't have to have a slab construction. We can have many different types of roofing systems, and we can use, quote, weak materials like earth for roof systems if we use it in compression, like in an arch or a vault. And this vault system is about 65 tons worth of mass material. So it's a very heavy roof using a lot of earth. And of course, a lot of studies had to be done for the stability of this vault as well, which is rather another lecture. Just to get a view now, this is the raw structure of the roof itself and its thickness. It's very, very thin. It gets down to a very minimal thickness at the crown, and is much wider, a little bit wider at the base, 24 cm at the base. To give you an idea of the raw construction. And voila, the final building, a few images from the outside, from the north facade. And so, you know, I start with the question is, can buildings improve local ecologies? And what does that mean for the aesthetic of architecture? What does that mean for the aesthetic of construction? What does that mean for the socioeconomics of construction when we have essentially 2/3 of the construction of the cost of construction is going into man hours? So, or it can be as much as 3/4 of the cost of construction is contributing to local livelihoods, as opposed to buying my solar panels and my UV treated glass and all my aluminum fenestration and all of my fancy gadgets for my LEED rated building. So there are aesthetic questions, there are socioeconomic questions, there are a whole series of questions that I think are, you know, in this day and age, important to ask about what is the impact on the local ecology itself, and how does our culture of construction, including our livelihoods in construction, how does the culture of construction impact ecology? So now we have this completed campus, and the entire quarry, which was an abandoned quarry, which was really like a desolate landscape, has been totally resculpted. We have a few beautiful buildings, but the buildings really have moved all of this mass and soil from one place to another in order to, well, I'll just go back, and in order to channel water in a way that sustains the whole ecology of the city of Pondicherry. And in water scarce places like India, we're actually urgently needing to ask these questions right now. You know, this is just, I mean, a kind of hope for my own practice, that I'm just beginning to get to the point where I can say yes, affirmatively to the question, do your buildings effectively work towards improving local ecologies? But it's just a beginning, and I think that for architects and for the culture of construction globally, it's just barely the beginning. We have a long way to go. So I think that I'll leave it at that, and then I'll leave space for some questions, and hopefully we can have a lively discussion.
Wonderful, thank you, Lara. This was really so inspiring and amazing to look at, both really beautiful examples, old and new, your current work, and seeing the monastery around the corner. Just so incredible, the long tradition of creating amazing architecture with these simple means, and the way it challenges the established systems that we're so used to. And I love the way you undermine the general belief in LEED certification here in the United States. And I think that was really just uplifting and enlightening. There's a lot that we can also apply in this country, and should. You know, it's really one path to, as you called it, circular ecologies, and having a real impact on you know, the well-being of populations of different groups. I'm thinking, of course, of the long tradition of adobe building in the west of the United States, with native populations have engaged in that, and hopefully are rediscovering those those approaches. And so this was just absolutely delightful. I can't thank you enough. It's really so much to talk about. I think Sabina sent out a little note if you have questions, which we hope you do. One way of doing it would be if you just send me a quick chat. Maybe we can get out of Lara's, or I don't know if we want to go back into it if someone has a question, but otherwise I see more of the.
Let me see how I can make this work.
Contributors.
No.
So please send me a little note in the chat if you have a question for Lara. There's a lot to talk about.
How do I stop sharing?
I think if you go to, probably should, if you hover over the top of your screen, there should be a little red thing. It says stop sharing.
Okay, wrong side. Hold on, technical. There we go. Okay, great. Okay, yeah.
All right, so while you think of your questions, maybe I'll start. You worked on a whole number of projects at MoMA and others, and what would you say is sort of the path and the obstacles of bringing this totally different approach to building to a country like the United States or Switzerland or others? What are the paths and what are the obstacles that you see?
Well, I can start with obstacles. You know, we know that Rafael Guastavino, which was studied very much by my mentor, John Oxendorf, that his very successful company went out of business finally because rising cost of labor. And this is one of the hugely prohibitive factors in labor-intensive construction in the United States, because, of course, we can't afford labor-intensive construction. And you mentioned adobe construction in the American Southwest, but I don't know if you know that in places like Albuquerque and so forth, adobe building is for the richest of the rich now, which is really amazing, because in countries like India, where labor is still affordable, you know, this is the cheapest form of construction. How do we broach that particular obstacle? I think that this is above my pay grade. Mm-hmm. I think that, you know, I might just kind of stop it there for that moment, because, you know, we get into like a huge question about the value economics in the system that we have now. And in the end, what happens is that even craftsmanship becomes unaffordable. So your entire economy is based on the obsolescence of the hand worker. And I think that this is really a troubling trend in Western capitalism, and hopefully one that changes as the world is rapidly changing now. In the context of coronavirus, we're definitely going to have a series of massive changes that happen. What means, you know, this period of late capitalism that we're in right now what changes are already in process, and can we beneficially use this period of capital, of financial doubt in the world to actually shift the dynamics in what is considered affordable for society? I have no idea. Maybe none of us know yet.
Yeah, no, that's so well put. But I think, you know, partially your lectures and making the sort of knowledge about this better known is very much part of what we need to do. I've done some building work in Guatemala, and the psychology there is, and I've seen it elsewhere too, in Morocco and so on, where they have great traditions of earth architecture, but the psychology is so that you want to, or people feel that using concrete block is just more up to date and smarter and looks better than adobe or earthen structures, and so they switch to that. which of course have horrible, concrete blocks have horrible thermal qualities. And so, but it's really often a psychological approach that's needed to change as well. I have a question here from Cheryl Mason, and I'll just read it to you. And the question was if the local citizens were excited about this building project.
Oh, good question. Thanks, Cheryl. Good question. This particular building, yeah, I would say this particular building is really impressive for the local villagers. This actually is a village development center. It's a rural development center and skill building campus. So the clients, they wanted very much that that a center that's used for basically like grassroots level education in a wide range of different programs, from the village level to local youth and cultural programs, that they had the chance to see with their own eyes types of construction that actually add to the value chains, the value added chains in local economy. And I think what's most impressive for the local people with this building is mainly just the scale of the span, which is pretty unprecedented. And and also the use of earth concrete it's unusual right now, but it's something that's catching on very quickly because only a small amount of training is required. There's little to no prior prefabrication that's needed. So basically you just put your formwork up, you prepare your raw materials, and then you can cast a wall in a day. So it's extremely cheap construction, and it's already catching on sort of like wildfire. Or only a couple of years later, I'm seeing it used in some of the outlying areas. So local people mostly get wowed when they see something that they can use. Mm-hmm. And something that's cheap and that it's a good building material. They consider it, quote, baka, which is the quality house construction that's not only, you know, like a tool that they can take home and build their own houses and other structures with, but something that's also bringing architecture to a level that they had never seen before.
Thank you. Yuna has her hand up. Can you unmute? Yes, perfect.
Okay. Yeah. Yeah, thank you so much for your talk. I think this is just like really interesting. And I was sort of curious about, you mentioned, I think towards the beginning, about like the, like needing, oh, I don't remember the exact number, but it was like requiring at least some amount of water to turn the clay or soil into something usable. And I was wondering, like, especially in like communities where water is more scarce, like if that's an issue that you need to think about, like sort of in the construction itself of the material. And so like, I guess, yeah, like what strategies you might use to work around that or do that?
Yeah, good question. Very good question. So, you know, like I had said, when being in a new place, I mean, I always try to study things very carefully and try to understand what are the valuable resources that are available and what are the resources that are very much scarce, whether it's trees, wood, water, etc., and then adapt the building technique from that, not even just the material, but the technique of using it. So for instance, adobe is earth block that needs just a little bit of water to make the block, but compressed earth block, if it's stabilized, would need water for a period of 28 days to cure the block. And in some of the places that I've been working in the center of Algeria, right in the middle of the desert, you know, dunes as far as the eye can see, there's no water. available. I mean, there's plenty, just enough for basic needs in oasis areas, but there's no water to spare. And these are the types of places where we have to hedge that modernization drive that Diederik was talking about, this need to use modern earth building techniques with cement and lime and other stabilizing materials, because if we're in a dry climate, we don't have a monsoon, we don't have to put cement in the material at all. We don't have to cure block for 28 days. We can just use much more traditional building materials. And the added benefit is that when we have cement, our strength goes up, but our thermal qualities that we were talking about go down. So there's always this kind of balance. And I think, you know, the failure of our modern construction culture is that we're so brainwashed into a pro-cement lobby that all our structural engineers care about strength and nothing else. But we should never say only one quality is important. Strength and thermal comfort are very much at an equilibrium, and we need to look for every project what's more important here and there and tune it to the local resources and the water scarcity issues. And it's a very good question.
Well, thank you.
I see there's another question from Spencer. I'll get to you in a second. I just wanted to say, you know, what always fascinates me about, and the way you laid it out was just so beautiful, and both the scientific look at, you know, these different earths and how it relates to the climate and the range of approaches there, and actually the haptic beauty of all these different types of earth you laid out was so amazing. And I think to understand that this is a real tool, if it becomes better known and more applied, that would have an immediate impact on climate change, because half of the carbon emissions in the world that obviously are a major force there come from making buildings and making building products, et cetera, and most people don't even realize that. So what you're describing here is really a tool that is of absolute essential importance, I think. But anyway, on to Spencer. Hi.
Hey there. Thanks for your lecture, Laura. That was amazing. I had one question. I was wondering if these local communities you work with have practicing architects, or if there is a distinction between architectural design and construction, and if you ever consult them in your own designs.
So the question is, are there architects at the village level? That's what you're, well, I wouldn't say that at the village level there are, well, you know, contractors are basically acting as designers at the village level in India. It sort of depends on what area of India. It's a huge subcontinent, but in this particular area, local contractors really are, in fact, people build themselves, but less and less these days. And when you have, I mean, in India, there's some of the largest million housing project, you know, building projects for millions and millions of houses. But India is traditionally very strong in auto construction. So no architects, people building their own homes with, you know, parts of the collective of the, you know, families building something together for one unit of the family and sharing resources and so forth. And there are also systems like Vastu Shastra that are used that kind of take the place of an architect. There are traditional systems that that people ascribe to for proportions in their building. So they're really not like architects at the village level, but there are masons, there are contractors, and people who are still building their own homes. And we like to be able to train as many as possible from this level, but oftentimes at the Institute, we're educating a lot of college graduates of architecture and engineering, and we don't reach as many people at the village level as we can, except when we're doing like technology transfer projects. And that's why we have a sort of design build firm here, but we do a lot of what's called technology transfer projects, where we go out and we train people, or we work with local people to help them modify their own local materials as efficiently as possible. It's not always that we get a chance to do that, but we try to, it's because it's our target, we steer as much as possible our accepted projects into this type of direction. I'm not sure if that completely answered your question.
Yeah, that was great. Thank you.
Great.
So we have another question coming, and one of the participants, unfortunately, don't see the, and we'll switch over to Abu Bakr in a second. I just wanted to say I got a little thingy in the chat where one of the participants said, don't have a question per se, but I want to say how remarkable her projects are, extending the reach of architectural practice and even environmental ethics. Such powerful work. I couldn't agree more. So thank you.
Thanks.
Over to
Thank
Abu
you.
Bakr. Thank you.
Thank you very much.
Hello, amazing lecture. My question was that so I come from Ghana, and then I have a little bit of experience with making bricks. And so in this area, it appeals to the locals, but then it doesn't appeal to a lot of the people in the city. And so I noticed in this area, this form of building is competing with like other forms of construction which are not labor intensive. And so I was wondering, how do you make this an appealing or a sought after alternative to other forms of construction which do not require as much time and then do not require as much labor?
Yeah, good question. Very, very, very relevant question. It's not always an easy answer. I mean, when I'm assessing for different projects, I just try to study the local economy as much as possible and try to see what are the materials that are available. And sometimes just like a tiny tweak of an existing building practice can make a really big difference in this kind of question about local livelihood production or carbon emissions or whatever. Those are two of the really big benchmarks for me. But we have to sort of take off the rose-colored glasses of the engineer coming into a place and forget the expert view and forget taking knowledge from the outside into the local place and really see what's growing up out of that place that can be a useful solution for people. So sometimes local places have already found their own solutions, but they haven't quite figured out how to valorize it yet. And there's definitely a big divide between rural areas and urban areas. In places like Ghana, in India, it's a little bit different. Like everything is peri-urban here. But just as one example, the poured earth concrete that I mentioned in the second project, we spent about 8 or 9 years doing research for this technique. And finally, for this project, we were able to start experimenting with a larger scale building. But the research done over that time was basically because we knew that concrete is so prevalent here, and the knowledge and the techniques, the know-how for concrete use, mixer, vibrate, basic techniques, how people know how to work with the material, it's here already. So if we use the same type of shuttering systems, the same types of vibrators, similar types of, I mean, there are differences, of course, with this technique. So if we take a slump test, for example, which is not always done for concrete, then we have to use a lot less water than a traditional concrete. So it changes the technique somewhat, but at least it's in the same ballpark as a known technique. And I always find that the awareness, or the acceptance rather, of people for a technique is always much better when you're adapting the techniques that they know. And the techniques that are already infusing local livelihoods, I would always, even if there are places where traditional country fired brick is really successful and people are making a lot of money, like I would be, reluctant to say move it to a raw earth construction, because but we can always take two techniques and bring them in if they're similar in their nature, and always try to slightly improve the carbon emissions or slightly improve the money that people bring home in their own pockets, as opposed to pay out or, import of cement or import of other building materials.
Thank you so much, Lara. This was amazing. I know we had another question here, but we're out of time, unfortunately, because another event for some of us is happening at 1 o'clock. But this was so clear and wonderful, and really uplifting in a way to see the tools that are there. As you say, we need to really look at this moment of late capitalism and what can be done in many different ways to alleviate the sort of pressures that the market provides on an area of building and architecture, and instead move over to techniques and technologies like you've presented to us to really make a change. So it's very inspiring. I can't thank you enough. Wonderful, Lara. So we hope to have you back in person, and
I hope so
thank you
too.
again. We'll be in.
Certainly you can make my email address available to the class, and if there are other follow-up questions, please don't hesitate to reach out to me. But I hope when I come home the next time, I'm able to pop by for a visit with a mask or without a mask. We'll see.
Definitely. All right. Thank you so much. Yep. Bye-bye.
Bye. Thank you.
So much.
Thank you.